This is Duke University.
Thank you so much for being our distinguished alum this year. I'm so appreciative. Tell us a little bit about your work.
Well, my work sits between physics and biology, and I study the mechanisms by which organisms interact with the physical environment around them and with each other. So I borrow tools from engineering and physics to ask biological questions. And field work is really important to me, so I need to understand how things swim and fly through the turbulent wind or water where they live. And I need to understand the terrain organisms are operating in to figure out how their body designs work. So that's sort of an overview of the kind of thing I do.
How did you get interested in that area?
Well, I got interested in that area here at Duke because I had to be a teaching assistant to earn my living, and I taught Biology 1, and Steve Vogel was teaching it at the time, and he focused on fluid mechanics of organisms, how blood is pumped and how things fly, things like that. And he gave a lecture about the size of organisms and what a profound difference it makes. So a little fly will get its foot caught by surface tension in a drop of water, and there's an upper limit to how big vertebrates can be before we crush our own bones. And I had never thought about the physics of organisms or that size made such a big difference. In fact, he talked about how ants can't wear pants because the electrostatic attraction of the pant legs to each other was greater than the force they could exert to put their legs in. And so I went to him and I said, "Oh, this is the coolest stuff I ever heard. Can I be your student?" And he said, "No, because that's Steve Wainwright's lecture, and he's on sabbatical this year, so you just wait till he comes back and then work with him." So it was really, you know, being a teaching assistant in Bio 1 that I learned that you could put physics and biology together.
That's great. So that was one memory of your time at Duke. Do you have other memories?
Well, one other that really stands out for me, almost sounds sort of silly. We had this funky old room in the biology building that was used as a graduate coffee lounge. And we had this ratty old coffee maker, and we'd take turns making coffee. And I knew that at about 10 every morning, a bunch of people would show up and drink their coffee and start talking with each other about our research. And so a cell biologist would be listening to an ecologist problem, and a physiologist would be listening to a biomechanics person's problems. And we all started putting input into the discussion from our own perspective. And I think I got some of the best research ideas and some of the best feedback on what I wanted to do from my peers in the coffee room. And that's where I really learned that it's not good to sit in your silo and have tunnel vision. That looking broadly and listening broadly was a really valuable thing to make your own research be more creative.
And so that old ratty coffee pot led to new ideas.
Yeah, and a lot of jokes and fooling around too, but it was, and the idea that interdisciplinary collaboration is really worthwhile and where you might be more creative than just sitting in your little narrow silo.
And so those people around the coffee pot influenced you and your work. What other influences at Duke?
Well, another one, early in my career as an undergrad, all my classes were, here's the material, you know, understand it. And we never learned where that material came from. And so I didn't learn till I got to Duke that if you had a question about the world and nobody'd answered it yet, you could answer it. That you could do the original research to answer that question if it wasn't in the literature already. And I also learned to think critically about the literature. As an undergrad, it was like understand the science, and you can use that to answer questions on exams. But it was a class I took my first semester at Duke from Knut Schmidt-Nielsen, who was the great physiologist, the grand old man when I was a beginning student. And he used to talk about a research paper in lecture, and then he'd say something from the paper and start laughing. And I thought, how can he be laughing about this research paper? And what he had discovered is there's no control in this experiment, or he measured it that way, but that's crazy, or how can you conclude this from those data? And so I learned that you could look at the knowledge that had come before critically and accept some of it, but for the right reasons, because you'd thought about it critically, or dismiss some of it because they'd done something wrong, and you could learn from what they'd done wrong to do it better yourself. And so that was another big lesson from my very first semester of coursework here.
Now, you switched when you were at Gettysburg College. You started out as an art major.
I did.
And then you switched. What was the intervening factor? What happened there?
So I don't know if Duke does this now, but what Gettysburg did as a liberal arts college was require that whatever you majored in, you had to take courses in things that weren't your major. And so all of us, even in art, had to take a science. And so I took biology. And when I got into that biology class, what I discovered was that I was fascinated by natural form. And in my art, I had used it to make images. But when I got in biology, I thought, damn, you can understand how these forms work. And that's much more satisfying to me than just admiring them. And so I switched my major, I guess, near the end of my second year into biology. And then I was playing makeup after that. So when I got to Duke, I had to take a lot of basic undergraduate science classes because I hadn't had enough time to finish all of that when I was an undergrad myself.
Switching gears just a bit, you didn't discover that you had dyslexia until you were in your 40s.
Yeah.
But you've said that you think dyslexia actually helped you in your science. Can you explain that?
Yeah. So
and how it helped you?
So I'll first say how I discovered it.
Okay.
Is I won a MacArthur Fellowship, these Genius Awards, and they have these meetings from time to time. And at one of those meetings, I met Jack Horner, who's the dinosaur guy that they based the Jurassic Park character on. And he came to Berkeley to work at the Paleo Museum, and so he contacted me and said, let's go to lunch. And so I met him at the building, and we went to lunch and ordered. And by the time we were done, he said, are you dyslexic? And I thought, I don't know. Nobody talked about dyslexia when I was a kid. I have no idea. Why did you ask me? And he said, because I can't read. I'm dyslexic. And I saw that you did this and this and this and this, just trying to get lunch ordered. And so I think you might be dyslexic. And I thought, well, that's interesting, but I didn't think any more about it. And then in our building, they changed the locks on our labs from a key to a keypad. And I can't tell you where the numbers are, but they're not where they are on a phone. And I couldn't get into my lab. I tried and tried, and I couldn't get the numbers right. And so I went to ask to have a metal key. And they said, oh, only the police can have metal keys. And so I said, well, I'm dyslexic. I think I can't open the door. And they said, if you can prove it, then the Americans with Disabilities Act will apply to you and you can get your key. So I spent 8 hours being tested, and she said I was one of the worst cases she'd run into. So anyway, I was in my mid-40s when I discovered this, but then all kinds of things made sense to me. And so to get back to your question about how I think it helped my work is, for me, humanities courses like history and English literature were torture because I read so slowly. It wasn't physically possible to get through all the material in the time we had. Whereas science was always easy to me because if you understood it, you didn't have to read the book. You know, all my friends were memorizing the book, but I couldn't get through it. But if I understood it, when I went into an exam, I could just figure out what the answer was. And so I thought I was cheating, you know, at the time. But now I realize that when I learn things, the only way I can learn them is to understand them. I can't memorize anything. And so that's been a great help as a scientist. And then the other thing that's been good about dyslexia is that dyslexics, although we can't process visual symbols very well, we get all scrambled, we're very good at 3D visualization of structures. And so I can see a structure and envision what it would look like from all other dimensions. And we're also very good at envisioning how things change through time. And so studying fluid mechanics and how the turbulent structures change with time, or studying organism motion, or just the structure of organisms from inside and out is easy for me to visualize. So I struggle to read the papers other people have written about it, but when I just face nature, it's easy for me to see physical things.
My goodness, it must have been, I mean, to not discover until your 40s, but having done all of this work and everything before then, must have been at times just a struggle.
Oh, it was. And so what was great about learning I was dyslexic is like, God, that explains everything. Because, you know, I had to work so hard and work for so long to do anything. I just thought I was stupid but a hard worker, and so I managed to achieve tenure at Berkeley just by busting my buns. But now I realized I actually had some assets too. It wasn't just hard work. But I think because things are such a struggle for me, the written word, that I do work really hard. I learned to work really hard a long time ago. So.
My goodness. Now, as your biography noted, and that you've kind of touched on a bit, self-confidence was something you struggled with as a grad student and at times during your career. This is a common challenge for many of our graduate students. Can you talk about how you dealt with it and what advice you would give students who are wrestling with that issue?
Yeah, so I will say I came to Duke and I was wait listed, so I knew that I was the last person in my class who'd been accepted. So I knew I was dumber than everybody else. And then I looked around and everybody's from Harvard and Yale and Cornell, and I was from this little college nobody'd heard of. So I was scared and I worked really hard. And I ended up being really successful because, so I think lack of self-confidence is good in a way, because if you aren't debilitated by it, if you use it as a challenge to overcome, I think it helps you do the hard work that's required. I also think now, you know, here I am at Berkeley, this fancy pants place with all these famous people on the faculty. And every one of them that I've gotten to know well will admit that they feel like a fraud and that somebody's going to figure it out. And I think this fraud syndrome is very common.
Yeah.
And we've talked about it, and when we've also realized that if you don't feel terrified before every talk, you're going to end up being boring. And so that sort of stage fright and this, God, I'm in over my head and they're going to find out if I don't work really hard, I think actually helps, as long as you don't just poor me and think it's debilitating. And also, if you're passionate about the question you're addressing, you forget that you can't answer it. You know, you really want to know the answer and you just plow ahead and focus on that, and then you forget that you should be afraid.
What advice would you offer the graduate students who are graduating this weekend?
Well, I'll go through some of that in my talk, but there's sort of two lessons I learned along the way that I wish I'd known when I was at their stage. And one of them is that you should think of your career as a path and not a ladder. You know, a ladder leans against a wall, and when you get to the top, there's a preordained place you are. And if you fall off the ladder, that's kind of disastrous. And every rung on the ladder is some preordained step that somebody else told you to take. Whereas if you think of your career as a path, it winds through really interesting territory, and it may double back on itself, and there may be branches. And the whole time along the path is interesting. And the process of going along the path is interesting. And the most wonderful thing is that paths cross other paths. And if you can share your path with collaborators and other interesting people like those students in the coffee lounge, then it's so much richer. And so that's one message, is think of your career as a path, and the twists and turns are good things. And the other thing I would say is it's really important to do the very best you can about something you care about. And that's very different from trying to be the best. Because being the best means you're competing with other people, you're comparing yourself to other people, you can be envious, you can develop low self-esteem. But if you try to do your best, to do whatever you're passionate about, then that's really rewarding. And so, you know, you might be passionate about learning principles about how the world works as a scientist, or you might be passionate about bringing beauty to people through poetry, or you might be passionate about curing cancer. And so what you're passionate about is really personal, and then you have to just do your very best to move forward on what your passion is. So I would say those two things.
I think that's good advice for anybody.
Yeah.
You know, I love the metaphor about the ladder and the paths. Last question, but this is more maybe curiosity. How does the MacArthur Foundation let you know you won?
Oh, what they do, and I had a funny story about this, they call you up. So I'm sitting in my office and I get this phone call. And at the time, the person at the MacArthur Foundation in charge of the Fellows Program was named Ken Hope. So he said, "This is Ken Hope at the MacArthur Foundation, and you've been selected to receive a MacArthur Fellowship." And I thought, you can hope you'd get a MacArthur. This is some friend playing a practical joke on me. And so he then started talking about the fellowship and blah. And he finally said, "You haven't heard a word I said, have you?" And I said, "No, I'm trying to figure out who you are." And he said, and I said, "You know, you're some friend of mine playing a joke on me." And he said, "No, I'm not, but if you don't believe me, just hang up and call the MacArthur Foundation and ask for the Fellows Program, and we'll start over." And so I did. I called the MacArthur Foundation and I asked for the Fellows Program, and then I asked for the director, and they said, "Oh, you mean Ken Hope?" And I thought, Lordy, it wasn't a joke. And so then when he answered, he said, "See?" And then when I talked to other MacArthur Fellows, they had similar, you know, I mean, some of them weren't as foolish as I was that I had to actually make another phone call. But, it's hard to believe,
thinks, right?
Yeah.
that you're going to be one of the chosen geniuses. Yeah. Mimi, thank you so much for agreeing to the interview and for being the Graduate School's 2018 Distinguished Alum.
Well, I have to say I'm more thrilled about this than any award I've gotten, because you sort of want your teachers to be proud of you. And so to have Duke recognize what I've done with my career that they set me out off on means more than other things.
Mimi, thank you again.
Thank you.